All right, now we're going to move on to section 6, or unit 6, section 4, practice lesson. This is all about the sequences of transformations involving dilations. So let's get right to it. So this is saying that we have triangle XYZ is the result of a series of transformations of P dq. The unlabeled triangle is the first transformation. So we have this is our pre-image. Right? This is the first transformation, and then this is the second transformation. So this would effectively be P prime, D prime, and Q prime. And then this would be, well, I guess I'm putting ahead of myself a little bit. You have to figure out, describe the first transformation. Okay, so I guess I'm going to erase this, and I'm going to name this ABC, because I'm going to pretend I don't know what it is. All right, so A, B, C. All right, so to figure out the first transformation without patty paper, I could just figure out with patty paper and manipulate that, figure it out. But I'm going to use point comparison. All right, so I'm going to say I'm going to compare point D to point B. All right, so point D is -2, comma 4, and point B is -4, comma -2. Right, and look at that. I have looks like I have a pretty solid point comparison. Right, so and I kind of recognize here that these are all the same distance from the y-axis. Right, so if this is this here, actually this is wrong. This is 2, comma 4. So it's x and y, x comma y, but my x value changed from negative to positive. Okay, so this is a reflection across y-axis. So this is what happened. This is a reflection across y-axis, and the transformation, and that is the algebraic expression for that is x comma y with this thing at the end, negative x comma y. Right, so that is that. All right, so the second transformation, describe the second transformation. Well, it looks like I have everything oriented the same. Right, so this is like the same slope as this. If I wanted to verify that is the same slope, my change in x and my change in x is 2 for a change in y of 2. Change in x is 2 for a change in y is 2. So that's the same slope, right? Then my change in x here is 2 for a change in y is like 3. My change in x is 2 for a change in y is 3. And then here my change in x is 3 for a change in y of 1. The same here. So this and this are the same orientation. All right, so that means I just have to like do a transformation here. So I'm gonna look at this point and this point, which are corresponding points, my c and my x. Right. So my change in x, my delta x, equals my final value, my final value, which is my point y x value, minus my point c x value, and my change in y is my y value minus my cy value. Sorry about that. My cy value. That's going to be equal to my x my c, my point y x value is -4, -4 minus my cx value is 4, so it's going to be -4 minus 4 is -8. Right, so move to the left, -8. So left 8 units. This is a translation. Left 8 units, and then y, it went from, my final is -4, or sorry, that's wrong, -1, -1 minus 2 equals -3 units, down 3 units, right? So that's my translation, down 3 units, and left 8 units. Algebraic expression for that, x comma y, x minus 8, y minus 3. Simple as that. Didn't show you that. Okay, so there you go. That is that one. Explain if the transformation preserves distance. Yes, it does. Both transformations are rigid motions which preserve the measures of line segments, therefore distances are preserved. Okay, so moving on to the next page here. All right, so the next page says I have 2 quadrilaterals. Oops, I have 2 quadrilaterals here, and there's a result of a transformation here. Okay, Ian and Natalie were determining sequence transformations, but each came up with a different sequence. Okay, figuring out which ones are correct. Okay, and why. Okay, so Ian's written description is rotation about the origin. Maybe zoom out. I can't zoom out. Maybe I can maybe bring it up a little. All right, there we go. So my rotate about the origin. Well, my x comma y, and my algebraic expression for that is -x and -y, if you remember that. And then my first transformation, this is a dilation with a scale factor of 1/2 at the origin. So this is a dilation of 1/2 scale factor at origin. Okay, and then the next one is saying, hey, this is dilation 1/2 at the origin, which is the same thing as that. X comma y, 1/2 x comma 1/2 y. And then look at that, that is still a rotate 180 about origin. All right, so the question is, well, will I have the same image if I do that in any order? Right, so let's see what happens if I do that in any order. I'm gonna grab the patty paper real quick. Or I can do it with just some simple, let me just do it with some math, I guess. Let's do it with some math. Well, let's see, if I rotate this guy, and what's it saying? KGY is, so this is the image, pre-image, and this is the image. Okay, so I have this one. Okay, and they're saying that if I rotate it and then shrink it at 1/2, it will be here. Which, so if I rotate it and then shrink it, it's gonna, so that's, I'm just gonna look at T here. So it looks like E and T are corresponding points. So if I went to here, it would be 1/2 and 1/2, right? So that would be true. And then if I shrank it, it would be, first, it would be 1/2 and 1/2, which would be here. And then I rotate it, then it would be, and it would be there, which looks like it's true. So that means that both sequences are correct. So I only need 1 point to really determine that. Okay, so hopefully that helped out. If you wanted to do the entire image, you could, but I really only need 1 point there to figure that one out. So I hope that helps out.